we'll be doing problem 9 from chapter 7. And part A and part 9, problem 9 is asking, consider a uniform gravitational field, a fair experiment near the surface of a planet. Find this equation where that express your answer in terms of mgy. Okay, so since both gravitational forces and distances are parallel to each other, then we'll reduce the expression into this. So we are given the expression u y f minus u raised to 0 integration of yf 0 fg times ds. Alright. And what we're going to do now is turn this into du is equal to f ds. And then turns into u integration of yf y0 f to the dy. And then we'll plug it into the equation. Uyf minus u y0 minus f times f minus y0. And then what we'll do is we'll solve and substitute by u yf minus u y0 equal to mass times gravity minus whatever's in the parentheses 0. And this will be our answer for part A. Now, part B is asking, consider the forces exerted by a spring that obeys Hooke's law. Find this equation where f of s minus that, and the spring constant k is positive. Alright, so we're going to use that expression right there, which is part B, and u x of minus u 0 is equal to 0 to the f and now we're going to plug in that for f of s in there and that for that in there. Okay? So negative integration xo of negative kxi dx. That's plugged in. Now we're going to solve the integration of that, which will be kx squared over 2 x of f x of o. Now if we solve that, it'll give us k over 2 x of f squared times x 0 squared. That'll be our answer. So our complete answer should be u x of f minus u, x is 0, k 2, and that's how we'll write the full answer for part B. Okay, now part C is asking, finally, consider the gravitational forces generated by a sphere, symmetrical, massive object. The magnitude and direction of such a force are given by Newton's law of gravity, where ds equal to dr, that. Okay? So we're going to use this equation again. Square. We're going to solve. Okay, so now we're going to do the integration 1, so x of f, r 0, g times ds. Okay, and for this, we're going to plug in there. And since we'll do u sub, and that'll cancel out this. Okay. Now we'll move the top part to the outside. And what will remain in the inside is going to be dr over r squared. And if we do the integration of that, it should be -1 over r rf 0. Now we'll solve this inner part first. It should give us -1 over r f 1 over r 0. Then our answer should just be this. This will move down, and then you'll solve this basically by doing -1 or RF, just plugging them in the inside and then subtracting it by the other side, but it'll just keep that. So the final answer will be u to the RF or 0, and then that should be our answer for part B.